There is a force so powerful that it can transform industries, disrupt the status quo, bring people together across time and space, and redefine human experience. That force is innovation. And in today's connected world, innovation is everything. We believe innovation is the engine of differentiation and the driver of success. And that value is created in the intelligence of things. We believe in the power of connected intelligence to build a brighter tomorrow. That's why we help the world's biggest brands and smallest startups across every industry bring intelligent things to life. So free your imagination, adopt the Maverick paradigm, and together, we'll change the world. Flex. Live smarter.
What I really wanted to explain why we showed the video is, yesterday there was a conversation going on, is IoT is still yet to come. Everything you saw in that is something which is actually happening today. Those are real examples of real solutions and real technologies that are putting into motion. And in today's talk, I'm going to show you how we bring a framework of how do you build solutions like that collectively, and how do we bring it to market collectively, and what are the challenges that we're going to have to tackle collectively, and eventually where we see the opportunities from IoT down the world. If you take a look at some of those examples that we showed, so for example, in the case of connected transportation, just take a step back and look. In 2015, only 15% of the vehicles that were sold had embedded connectivity built into it. By the year 2020, 90% of the vehicles out there are going to have embedded connectivity. What that means is, since you know that car life cycles from a development standpoint are roughly 3 years ahead, the car companies, OEMs, are working on that today itself to bring that to market. Another example, if you look at, for example, digital health, which you saw in the video, the digital health market in 2015 was only $6 billion US. And I say only. The reason is because by the year 2020, that number is going to be almost $100 billion of opportunity out there of how we bring digital innovation into the medical market and bring new solutions to market. If you look at smart agriculture, just take an example. In the year 2000, there were roughly about 500 million farms across the world. With a simple vote of hands, how many of you think that there were sensors in those farms at that time? The answer is 0. There were no sensors embedded in farms in 2000. By the year 2025, we're expecting 600 million sensors to be embedded that will be looking at the crop health, which will be looking at water, which will be looking at nutrition, and providing that real-time data to farmers and to the markets to predict. Take an example of smart retail today. The very fact that now not only can you go into many of the stores and through your smartphone and the apps and everything else, you get a lot of information, or even online, but to the point where now with basically AR technology or VR technology, you're able to actually shop virtually. So for example, if you look at what Alibaba has been doing through their store models online, you're able to do things like this. That's really advancing what is happening there from that standpoint. And if you look at industrial automation or even Industry 4.0, one of the biggest use cases that we are seeing right now is how you are able to do predictive maintenance on machinery and on the factory floor. And essentially the robots and the different machines that you have that are running your entire supply chain, you can anticipate when they're going to require maintenance. You can anticipate if there's a problem. And you can solve that ahead of time rather than waiting for something to happen, or rather than having to have a whole staff of people having to go and check it periodically from time to time. Also, you can take the same approach and expand it even further from a machine learning or a deep learning standpoint, where, for example, you can use vision systems that look at the finished product and can learn in under 24 hours what a final product should be like, what the quality should be like, and therefore, as you run products through there, they're able to instantaneously determine that there is an issue, that there's a defect, where the defect is, how significant it is, and what should the quality response be. And then, of course, in connected home, I'm pretty sure all of you have some form of connected home engagement today off of your smartphone. It might be security. You may be able to open and close your garage door, or turn on your lights, or lock your door, or just monitor things in the house. And that's become something which has become very common right now, when before the barrier to entry was really the cost. The cost to do an automated home was quite expensive in the past because it was all proprietary technology. And now you're seeing, with the advent of IoT and with the advent of the cost structures, of how inexpensive it is to do this, and how everything is running off of a simple platform like a phone, in this case, for what you interface with, it becomes extremely easy. And then finally, when you put all this together, and we heard about the minister yesterday talking about smart cities, and for example, the digital nation initiatives that are happening here in Singapore and across the world itself, you start to see how these different systems, all these different examples, are now talking to each other. So cars talking to the infrastructure, such as the traffic lights, and pedestrians talking to the retail environment, et cetera, et cetera, et cetera, is really bringing a smart city to life. Now, the reason I show these different examples is really, if you take a step back, there's 3 observations I'm assuming you have made by now. The first one, which is pretty clear-cut, is the opportunities are in every sector that you can imagine. If you look at, for example, in healthcare, we talked about the example of digital health, and how, for example, even something as simple as being able to address chronic disease management can have a significant impact, economic impact, in healthcare. Or something, what we talked about in the area of connected cars, and how you can actually use that technology to reduce the number of accidents, and as a result, the cost savings that come from vehicle damage, repair costs that now go down, and the benefit not just to you, but also to the insurance company and every part of the supply chain that goes into it. And then, of course, in energy, with the advent of the smart grid and the whole initiatives to bring down the operating expenses of running and operating a grid, and making sure that more of the electricity that's generated actually reaches your home and actually turns on the light bulb than gets lost across the way. The second observation that hopefully you have made from this is that no one company can do this alone, no one organization can do this alone. There's a need for us to all collectively innovate and work together, because everyone brings a complementary part of the solution. The solutions that we showed on the previous slide are just too big for any one entity to try to accomplish it. But the second thing, this is not about outsourcing to somebody else to help develop different parts while you focus on your own. This is really the need for everyone to start to build an ecosystem of partners and say, how can you work together to co-develop a solution, to co-develop an opportunity? And then essentially, it gives you several benefits. For example, quicker time to market, better reliability, and also it allows you to move into adjacent markets that you might not have had the ability to enter into. And the third observation, and probably the most controversial observation that I will say over here, is it's not about the internet alone. The Internet of Things gives so much of importance to the connectivity. Now, no doubt, connectivity is important. Obviously, that is kind of what ties into these different devices. But as the previous speaker spoke about, it's really about putting intelligence into the platforms themselves, into the solutions themselves. And that's really what brings in the 500, or actually the 50 billion devices you keep hearing people talk about that are coming on board and that will be coming on board over the next 5 to 10 years. And these can be devices, they can be machines, they can be systems. The other part that we also heard about is regarding the smart, or the intelligence aspect of it, from a data analytics standpoint, or things that occur in the cloud. So when you put all of this together, that is really what we are calling the intelligence of things. Because this is really what has changed. The internet was there 20 years ago, but what has changed now is the ability of all these 3 vectors to simultaneously converge and give us an opportunity to start to build new capabilities and new technologies. And what that looks like today is what you see over here. So for example, from a platform standpoint today, we have advanced from servers and computers all the way to smartphones and wearables that are now acting as the new platform on which solutions are being built. From a connectivity standpoint, we have things such as, from a cellular standpoint, you got 4G and LTE. Obviously, there is Ethernet. And then there is a whole flurry of wireless LAN technologies and wireless technologies that are currently enabling the connectivity. And then finally, to the smart part, like we talked about in the examples, we have predictive analysis. We have automation, which would be either in the industrial domain or other tasks, routine tasks, such as in your home, that now can get automated. And then, as was spoken about earlier, natural language processing. One of the interesting things, for those of you who had attended the Consumer Electronics Show this year, is you would see the rise of how voice-enabled engagement between systems, not just a recognition of voice, but how the systems will react back to you, whether it be an Alexa, whether it be a Siri, whether it be any other system, and now get embedded into devices that you commonly use. It could be, for example, the fridge in your house. It could be your entertainment system. It could be other systems that you normally engage with, are now having that level of interaction. That's where we are today. So you can see there's a lot happening today. Now, the fourth observation that I would like you to make is, as you go to build this, there's a need for a framework of how do we collectively look across and say, how do I decompose all these opportunities into simple things that we can look at? And what I will say is, let's take three very disparate use cases. Let's look at, for example, health. Let's look at consumer, and let's look at automotive. Each one of these are very different. Obviously, connectivity is common across the board. The type of protocol we may use, the type of approach we may use may differ, but there is definitely the need to have deep understanding of different type of connectivity technologies, because each of these solutions require that as a building block. But there's 6 other building blocks. Think of them like Legos that you can actually start to put together. You can build any type of an IoT device that you need by leveraging these. So for example, flexible technologies and miniaturization. Very important for wearables, very important for some of the new health systems that actually go onto your body. If you took, for example, a smartphone today, and if you looked at all the circuitry that goes into it, you're looking at probably a circuit board that's in the ballpark of 15 centimeters by 15 centimeters. Now, I don't know about you guys, but I have not seen a person wearing a smartphone that's 15 centimeters by 15 centimeters. The ability to miniaturize all of that capabilities and technology down to a form factor that you can wear on your hand that has the flexible, bendable, stretchable capabilities and properties needed to pack itself into such a small space and to survive and to be reliable and robust in that space is really where we're seeing a lot of technology advancement happening. Battery and power, each of these technologies, of course, are going to require some power source in some way to provide that. You have sensors and actuators. More and more different type of sensors are now getting integrated and embedded into these wearable devices or the automotive devices or any type of health device. You have the smart software that we talked about earlier that basically provides the application, the capabilities, the intelligence required. Human-machine interface. This can be, for example, how you interact with that device. It could be through a traditional display. It could be voice-activated. It could be tactile. You could touch it, and it responds back to you. And how it provides feedback to you as well. A lot of things there, whether it be audible, whether it be through haptic feedback. And then you get to, for example, security and compute. Probably one of the more challenging areas in here is on the security aspect. How do you ensure that security that you are used to in other domains, like such as enterprise, and how do we bring that into some of the applications we're talking about over here? And also, how do you bring compute capability down to these individual devices so that when they do act as a platform, they have the capacity and the capability to do that? So obviously, there are some challenges. For example, if you look at the case of battery and power, most of these devices that we're talking about that are not connected today are not connected to a power source. Very few things, such as smart meters, are already by inherent have electricity coming to them and therefore can leverage off of that. But if you look at other large problems to solve, whether it be water distribution, whether it be gas distribution, whether it be embedding smart devices on your remote locations, you need to have a way to have power provided to it. Also, as you look at something as small as a wearable device, or even a medical wearable device, you need to, how do you get the form factor down to a point where the size and the weight can package inside of such a contained space and still provide the battery life that is required. Another challenge comes to connectivity. So we talked, of course, that there's a lot of advancement in connectivity. But now you get to the point of, as you bring on video, as you bring on machine learning, as you bring on a lot of the artificial intelligence type of capabilities, or even AR, VR, that's not enough data rates to sustain that. You've seen the numbers in terms of how much of data is available from a big data standpoint. How do you bring that information in real time across? Cannot be sustained by some of the examples we were talking about earlier. The second thing is, as you take some of these technologies that exist today and start to embed them into these devices, the power consumptions do not make them viable solutions for long-term applications. So for example, even Wi-Fi, the power consumption of that module to put it into a small endpoint precludes it from a wide distribution of applications. And then when we get to security, what has happened over here is that as you start to bring more and more devices onto a connected infrastructure, you have actually increased the opportunities for attack. The term that you've heard many times, especially those who come from the security space, is you've increased the surface area of attack. The vulnerabilities now are much more to hack into it. The second thing is that there is really minimal level of cyber protection on many of these, especially in the consumer type of devices, compared to what we're used to in the enterprise domain, where you have a variety of different capabilities to prevent, whether it be a denial of service attack, whether it be address spoofing, whether it be something else. These don't always exist today at that level. And then finally, authentication. Now as you start to bring more and more devices on, how do you know you can trust the new device coming on board? How do I know I can trust the device you're wearing to come onto a protected network, onto my network? Where is that level of authentication that exists that allows me to do that? Now those are the challenges, but it doesn't mean that those are holding us back today. Because for example, if you look at some of the initiatives that are currently underway, let's say for example in the case of battery and power, there is a whole lot that has been occurring right now, for example in printed batteries. The very fact that now the actual weight and the actual size is not really a constraint anymore, is really something that enables a lot of new opportunities. It also enables it to go into form factors like we talked about that can be bended and flexed and stretched that could not happen before. The other thing is, how do you actually harvest energy out of the environment? So for example, there are devices right now, so imagine a light switch that just purely by the force of you pressing the switch causes enough friction that generates enough of an electrical pulse to send a command through over, say, Bluetooth or other form of communication to turn on a light bulb. So now imagine if you are in the construction business, you can actually go into an existing, what we would call a brownfield building, an existing building infrastructure, and you can put light switches wherever you want without having to run wiring to it. Suddenly allows you to do a lot more than that. Now, of course, you can take energy harvesting down to the devices you wear, and now you don't have to worry about battery life as much as you had to before. This can be a supplemental source in addition to the battery that you have. Think of it almost like the equivalent of the hybrid electric car now worn on your wrist. And then finally, the advances in wireless charging. As you start to see, there have been several different protocols, whether it be Qi, whether it be the PMA and others, but now you start to see a convergence of being agnostic to the protocol so that you can now wirelessly charge multiple different things in multiple different environments. And that really extends, A, the life of your device and its functionality, and also it helps you reduce the size and reduce the weight issues that have been a challenge. The other aspect from connectivity is the advancement we're seeing in what's called low power wide area networks, or LPWAN. We heard quite a bit about this yesterday in the keynotes, and there's a variety of different technologies, whether it be looking at LoRa, or whether it be looking at Sigfox or others who are having essentially similar and different approaches to try to address that solution over there. You also have a great improvement in the cellular side of things. So for example, 5G networks, we're starting to see the first instantiation of that in the form of narrowband IoT, where it's a much more lower power consumption, but at the same time it gives you 10 times to almost 100 times the data rates of what you can get today. So therefore now you can take that type of technology, apply it onto a small device that before would have been cost prohibitive, would have been power prohibitive, and now you can start to enable many more of the use cases we saw in the very beginning. And then finally, from a security standpoint, you can start to take some of the capabilities that have been developed on the enterprise side. So for example, the ability to set up in hardware a root of trust, where basically you now have a layered approach to security built into your system itself, and it is interoperable and it's comparable to other devices that are coming on board. You can also look at how you do mutual authentication between devices and leverage capabilities that already have been built there in terms of doing that. And some of the benefit you get from this is you see that now you get improved cyber protection, which is one of the key concerns. You also are able to address data privacy concerns. And then also now you have secure access control. So now if we look at where is the intelligence of things going, we saw where we are today. When you start to take these three different capabilities that are allowing us to extend the initiatives, you can see now where we are able to go over the next couple of years. So we're able to go from predictive analytics, where we are basically trying to predict what is going to happen, to be prescriptive, to get to the point where not only can we anticipate what's going to happen, but we can now prescribe how to respond to it and automate how that whole process goes about to actually respond to an anomaly event. We talked about the natural language processing, and now you get to full level of voice interaction. We saw some examples in the prior keynote, and you can see that is being enabled now by these type of technologies, this level of smart intelligence, whether it be artificial, whether it be machine learning. And machine learning is one also that's providing a whole bunch of new capabilities that we see right now in the market today. Because now, for example, the fact that you can program a machine to learn a capability and apply it, not just in a gaming environment, but now in an enterprise environment, so that we talked about the example in Industry 4.0, that how it actually will learn and say, this is what the product should be like. And then if it starts to see products that don't meet that, it automatically is able to reject and provide information on what to do. You can see, for example, what we talked about in the connectivity part of it, of how we're advancing beyond where we are today from a technology standpoint. And now with the advent of LPWAN and with the progress that's happening in 5G and where we expect to be in a few years, of how that's really going to revolutionize the number of devices that can now be connected onto the infrastructure. And also it's going to enable new platforms. Because now when you have that level of capability in terms of data rates, in terms of security, you now can move from just smartphones and wearable platforms to fully AR, VR platforms. It's no accident that Facebook decided to purchase Oculus. And they weren't doing the purchase because they thought this is a great gaming platform for us to have. They're anticipating, where can I go with this from an enterprise application, from a full application? We ourselves have been using VR for the last year and a half, where, for example, in a warehouse environment, rather than having a person going around with a scanning tool in their hand and scanning different barcodes in the warehouse and doing inventory tracking, you can now wear an augmented reality goggle interface. And essentially, they have their hands free. It's providing all that information of scanning the information, providing them checks, providing them other information that they can now send back to the centralized locations. And we see great productivity benefit that comes from that. So we're actually going to see a lot of these applications happening in the enterprise domain with use cases that all of us can truly benefit from today, in addition to where they may be in other domains as well. And then finally, the smart devices, the very fact that not only are you connecting devices, but now these devices can act as their own platforms, is really something which is going to revolutionize what we call IoT, and I will submit to you what we should be calling the intelligence of things. And so now, if you start to sum all of everything I said together and bring it together, the first part I mentioned is there's a need for us to look at how do you cultivate, how do you nurture an ecosystem of innovation among your partners or new solution providers. Look for what are the big problems that are worth solving and look at how collectively we can approach that. The second thing is, remember I mentioned that there were those 7 different building blocks. How do you go about and develop capabilities either in those building blocks or find people who have those deep capabilities so you can leverage it? Because essentially, if someone has invented the wheel, there's no point you trying to reinvent it inside. You might as well leverage it because technology is moving so quickly, there's no way you're going to be able to do that internally all by yourself. And then finally, look at use cases, not just within your own domain, but look at use cases outside of your domain in other sectors. There's examples for where we have taken a technology, for example, that was a medical technology, such as microdosing, that's used for putting minute doses of medicine, and apply it to something entirely different, like a beverage dispenser, so that now you can get essentially 120 flavors of your favorite soft drink, that before you were limited down to maybe 5. So that's taking a technology from one application and taking somewhere else. And finally, when you get to commercializing, and how do you bring these things to market? Many a time what happens is someone goes off and looks at developing a technology without really understanding what is the problem that you're trying to solve. So here, look at essentially what are these big problems, and I showed you essentially 6 big sector problems that are out there to be solved today. And then look at how do you commercialize it by taking all these different things, this framework that we talk about, an ecosystem approach to IoT, and then go from there. And with that, I thank you.